Hey, it's Mr. E here, and our aim for this video is how do we apply the double angle and half angle formulas for trigonometric functions. So these are the formulas, these are the formulas we are going to be using today. So make sure that you are familiar with them. Don't have to worry about memorizing them because they will be provided for you on all exams. Okay, so here is our first example. Using the half angle formula, find the exact value of the cosine of 15 degrees. So here is our half angle formula for cosine. And 15 degrees is half of 30. So my A is going to be 30 degrees. So let's substitute that 30 into the formula. We're going to get cosine half of 30 degrees, which is cosine of 15, is equal to plus or minus, and you're just going to substitute 30 degrees for A in there. Now we're just going to simplify. So what is the cosine of 30 degrees? The cosine of 30 degrees is radical 3 over 2. So this is what we get when we substitute radical 3 over 2 for the cosine of 30. Alright, now look. This part over here in the numerator, this 1 plus radical 3 over 2, is an addition of fractions. So let's just take it back a little bit and go over that. So 1 plus radical 3 over 2 is like saying 1 over 1 plus radical 3 over 2. But to add these two fractions, you need a common denominator. So to get a common denominator, I'm going to multiply this by 2, and I'm going to multiply this by 2 to get a common denominator of 2. So in turn, I get 2 over 2 plus radical 3 over 2. And this is going to simplify to 2 plus radical 3 over 2. So my numerator now looks like that. Now you're probably just wondering, whoa, that just looks a little more complicated because you have a fraction here divided by a whole number. And indeed you do. So let's think about it this way, right? We got 2 plus radical 3 over 2 divided by 2 here in this radical. So another way to write that is like this: 2 plus radical 3 over 2 divided by 2 over 1. And do you remember how to simplify this? You're going to change the division to multiplication, and you're going to flip this fraction over here. So it's going to be 2 plus radical 3 over 2 times 1 over 2. And in turn, this is what you get. 2 plus radical 3 over 4. Now, what's that going to simplify to? Well, you got to remember, this radical here applies to the numerator and the denominator. So this is what we end up getting. Now, we're going to take the positive answer. Did you notice that I just got rid of the negative and I just kept the positive? The reason the answer is positive is because a 15-degree angle is in the first quadrant, and in the first quadrant, cosine is positive. So this is our final answer over here. Let's try one more. If x is an acute angle and the cosine of x equals 4 over 5, then the cosine of 2x is equal to, and we got some choices there. So this is a double angle formula question. So we're going to be using our double angle formula for cosine. And I'm just going to substitute x for a, okay, and rewrite the formula with x. Now I'm told that the cosine of x is 4 over 5. So I'm going to substitute 4 over 5 for the cosine of x. So I'm going to get 2 times 4 over 5 squared minus 1 when I substitute 4 over 5. Right? Because the cosine of x is 4 over 5. So I substitute 4 over 5 in there for x. So what you're actually squaring is the value of the cosine of x. So 4 over 5 squared is 16 over 25, so I get 2 times 16 over 25 minus 1. And 2 times 16 over 25 is 32 over 25. So I get 32 over 25 minus 1. So now you're subtracting fractions. So if you go back a little bit to the first example we did, I went over adding fractions. I'm not going to go over subtracting fractions here. You all should know how to do that by now. But suffice to say that you have to get a common denominator, and then you subtract the numerators and keep the denominator the same. So your final answer is 7 over 25. Okay, now you try this example. So you're going to find for me the cosine of 2x. And I'll give you one hint. Okay, so here's your hint. You ready? You're going to be using this formula over here to find the cosine of 2x. Alright? Okay, work well. I hope this video helps. Take care.